All of this general work that Newton did could be made very specific for planetary orbits. Let's go into that. When we looked at Newton's third law, it was very broad, that said that gravitation was mutual, that it was equal and opposite, and that could be specific for the Earth and the Moon, could be specific for the Earth and the Sun, could be specific for any planets in the Sun, and anything in the universe. That law that said every action has an equal and opposite reaction could be both broad and specific for planetary orbits. In addition, the first law could be broad to say that an object in motion tends to stay in motion. That can be everything from an atom of helium that is zooming around in the atmosphere to a Maserati that's zooming around on the Autobahn. Or it can be specific to planetary orbits to say that the Earth was in motion since its formation in a straight line, and it changed its direction based on another force that acted on it. In other words, an object in motion tends to stay in motion in a straight line at a constant speed unless there's an external force. In this case, the external force was the sun. Now, Newton's third law, by those two constraints, says, well, if the Earth is pulling on the sun must be pulling on the Earth. Those two objects are mutual and universal. So if the Earth is pulling on the sun, that means that they must have a common center of mass. Because remember, the sun is pulling on the Earth is pulling on the sun. F equals ma in both ways. Well, the mass of the sun is so insanely massive that there's not too much acceleration that the Earth can do to grab it. On the other hand, when it comes to the sun pulling on the Earth doesn't have as much mass, but the acceleration of the sun is huge. So remember, those two F equals ma balance out, and they balance out at a common center of mass. Common center of mass is a lot like a seesaw. When you have people that have equal masses, you can put the fulcrum right in the middle. But if you had a large mass, two people on one side of the seesaw, you would have to put the fulcrum very close to the larger mass in order to have the fulcrum at the center of mass. So in terms of that, we could say that while Kepler said the ellipse had one focus and the focus was at the sun, actually the focus is not at the sun, as Newton was able to really refine Kepler's law. In other words, the center of mass is just outside of the sun. It's called a barycenter, meaning literally center of mass. Bary is a term from Greek for mass. When we talk about the center of mass between the sun and the Earth alone, the sun has so little mass to pull on, the Earth has so little mass to pull on the sun that it means the center of mass between the two of them is just literally just outside the center of the sun. It's not even outside the sun. When we're talking just about the Earth and the sun relative to each other. But when we're talking about the sun and the entire solar system, we really talk about the relative masses of Jupiter and Saturn, which together manage to pull this barycenter just outside of the sun, especially when Jupiter and Saturn are aligned on the same side of the orbit. It's kind of unpredictable because Jupiter and Saturn can be opposite in their orbit and cause this center of mass to wobble. I really recommend that you watch the video that's right after this in Blackboard to go into the center of mass issue about the sun and the solar system. It'll help you out quite a bit. But in the meantime, we can talk about binary stars, which are two different stars which can share a common focus and can orbit around the common focus. Or this is an approximation of a common barycenter between two of Saturn's moons. One of the moons could be Janus, and the other moon could be Epimetheus. They could have a common center of mass, a common focus right between the two. Of course, Saturn is also really impacting their orbits as well. But these two moons do impact each other's orbits. So all told, Newton's laws of motion and the law of universal gravitation really make it possible to explain the why of planetary orbits, to explain the why of Kepler's laws, and to make broad generalizations and predictions anywhere from molecular gravitation to universal gravitation. Newton was able to remake astronomy into an analytical science. It moved from philosophy to an evidence-based science, from a philosophy to a cause and effect principle. And it showed that the universe was rational. It was dependent on causes and on effects. Totally different change that really opened up a scientific revolution.